So here in this problem, we are given 3 points. These 3 points are collinear. If they are collinear, then we need to find out the value of k. So how do we do that? First, we'll make an assumption that these 3 points are the coordinates of the vertices of a triangle. So if we have a triangle ABC and we are denoting the vertex A at a coordinate k, 2 minus 2k. Then coordinate of vertex B, that's negative k plus 1, 2k, and coordinate of vertex C, that's negative 4 minus k, 6 minus 2k. Now, what we'll do, we'll try to find out the area of this particular triangle. Now, we can use this formula to find out the area of the required triangle here. X1, x2, x3, y1, y2, y3 are the coordinates of vertices A, B, and C of the triangle. So let's find out the area of the triangle. This will be equals to half multiplied to the absolute value of x1. So here we will consider x1 to be the x coordinate of point A. So that's simply k. And with this we'll get multiplied to y2 minus y3. So y2 we will consider it to be the y coordinate of B. So that's 2k. And from here we're going to subtract the y coordinate of point C, which will be y3. So we have to subtract 6 minus 2k. That means we'll get minus 6 plus 2k. Added to it will be x2. So what is x2 here? x2 corresponds to the x coordinate of B, that's negative k. So this will get multiplied to y3 minus y1. So this is going to be our y3 value, which is the y coordinate of C, and y1 corresponds to the y coordinate of A. So we have 6 minus 2k, and from here we're going to subtract 2 minus 2k. That means we get negative 2 plus 2k. Added to it will be x3. So x3 corresponds to the x coordinate of C. So that's going to be negative 4 minus k. Multiplied to it is y1 minus y2. So we have y1, which is 2 minus 2k. And from there, we're going to subtract y2. So y2 corresponds to simply 2k. We have negative 2k subtracted from it. Now this will be equivalent to half multiplied to, so we have k multiplied to, so we get 4k minus 6 minus k multiplied to, so negative 2k, positive 2k goes away, 6 minus 2, that will be 4, minus, this is negative 4, this is actually negative of 4 plus k, negative of 4 plus k multiplied to, so we have here 2 minus 4k. Further simplification is going to give us half multiplied to 4k squared minus 6k minus 4k minus, we have 4 multiplied to 2 minus 4k, so that's going to be 8 minus positive 16k minus 2k plus 4k squared. Fine. So we have now half multiplied to 8k squared, then negative 16k plus 16k is going to be positive 10k. 10k minus 2k, that's 8k. So 8k minus 4k, that's going to be positive 4k. Then we have negative 8. Fine. So this will be half, if we factor out 4 as the common factor. So we have 4 times 2k squared plus k minus 2. Fine. Now we can factor out 2 from the numerator and from the denominator. So we are left with 2 times 2k squared plus k minus 2. So that's the area of the triangle. However, we are given here the condition that these 3 points are collinear, meaning A, B, and C are collinear in nature. Now, collinearity means that any one of the point is going to lie on the line joining the other 2 points. For example, if we start with point A, so it's going to lie on the line joining B and C. Or we can say, if we consider the point B, it must lie on the line joining A and C. And if we consider point C, it must lie on the line joining A and B. In any of the case, the area is always going to be equals to 0 because they're collinear. That's the property of collinearity. So that means we can equate this to 0. So which implies we have now 2 times 2 absolute value of 2k squared plus k minus 2 equals to 0. Or simply we have 2k squared plus k minus 2 equals to 0. Fine. So this is a standard quadratic equation. So we can factorize by splitting the middle term. So we have 2k minus k minus 2 equals to 0. So if we take 2k as the common factor, we can from the first and the second term, so we're left with k plus 1. And we're going to take -1 as the common factor, so that get multiplied to k plus 1 equals to 0. Fine. So this will now give us k plus 1 multiplied to 2k minus 1. So that's equals to 0, which means that k value, that could be either -1 or it could be positive 1/2. So that's the value of k that we needed to find. So if we substitute the value of k with either -1 or positive half, then these 3 points are going to be collinear.